Hey there, peeps. We're on chapter 2. How does it feel? Let's talk about patterns and inductive reasoning. Alright, look for a pattern. What are the next two terms in each sequence? So, 3, then 9, then 27, then 81. What's happening from one term to the next? Let's see, are we adding 6? 3 plus 6 is 9. 9 plus 6 is 15, so no, we're not adding 6. How about multiplying by 3? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So cool, we're multiplying by 3 each time. Alright, so then what are my next two terms? The 81 times 3 is 243. And 243 times 3 is 729. Did you see that? I hope you didn't. Alright, so look at this sequence. Got a triangle and a circle, then a square, then a pentagon. So what's going to be next? Each circle contains a polygon that has one more side than the preceding polygon. Oh my word! So we're going to have a 6-sided polygon and a 7-sided polygon. A hexagon in a circle and a heptagon. Alright, pause and see if you can figure these out. Okay. 45, then 40, then 35, then 30. It looks like we're subtracting 5 each time. So 30 minus 5 is 25. 25 minus 5 is 20. Neato. Alright, here we got a square. And then we've got another square. It looks like it's made by connecting the midpoints of each side, maybe. And then there's another square inside of that one. Looks like it's made by connecting the midpoints of that side. So here, let's see what we got. So there's step 2. There's step 3. So then here's step 4. And then imagine I got another one right over here. Here comes step 5. What? Crazy. Alright, you want to find the 10th or the 100th term in the sequence. In this case, rather than, you don't want to write out 100 terms, you can look for a pattern and make a conjecture. So conjecture is this educated conclusion we reach, kind of like a guess, but smarter than a guess. And we use inductive reasoning. So look at the circles. What conjecture can you make about the number of regions that 20 diameters form? There's 1 diameter, 2 diameters, 3 diameters. So let's look at the pattern. 1 diameter makes 2 regions. 2 diameters makes 4 regions. 3 diameters makes 6 regions. So if this pattern continues, it looks like the number of diameters times 2. So if we get to the 20th diameter, it'll be 20 times 2 and make 40 regions. So see if you can make a conjecture about number 2 here. Pause it and then push play to see if you're right. So how about if we number these terms to get an idea here? This is the first, second, third, fourth, fifth, sixth, and we're repeating these 3 letters. RWB, RWB. Let's see, the 21st term is a multiple of 3. 3, 6, 9, da-da, da-da, 21. So it should be B, since every third number is a B. Coolio. And if you're wondering about the secret phrase, it is monogram out. Monogram out. Alright. It's important that you get enough information before you make your conjecture. For example, if you see this sequence, I keep saying sequence. Sorry about that. I'll try better. If you see this sequence, 1, comma, 3, comma, da 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 da, is that enough to make a reasonable conjecture? You might say, let's see, maybe it's 3, we're doing 1 times 3 to get 3, and then 3 times 3 would be 9. So it's 1, 3, 9. But what if it was 1 plus 2? Then we would do 3 plus 2, and the next term would be 5. So which one is it? The answer is we don't know because we didn't get enough information here. All right. So what conjecture can you make about the sum of the first 30 even numbers? Let's see. Find the first few sums and look for a pattern. So the sum of the first 1 even in even numbers. All right, so 2. The sum of 2 is 2. Okay, the second 2 even. 2 plus 4 is 6. Is there enough information there to start a conjecture? I don't know yet. We've gone up by 4, but what are we going to do next? 2 plus 4 plus 6 is 12. Well, what about this one? What about 4 terms? 2 plus 4 plus 6 plus 8 is 20. So let's see. 2, we go up by 4, then we go up by 6, then we go up by 8. And next we would go up by 10, and then we would go up by 12. But to do the first 30 terms of this is, I mean, we're going to have to go one by one if we do it that way. So maybe there's another pattern we can see. This one might not be super obvious at first, but this is, for the first term, it's 1 times 2. For the second term, it's 2 times 3 is 6. For the third term, it's 3 times 4, which is 12. For the fourth term, it's 4 times 5, which is 20. So each sum is the product of the number of terms times the number of terms plus 1. So to get the nth term, it would be n times n plus 1. To get the 30th term, it would be 30 times 31, or 930. So pause and see if you can make a conjecture about the sum of the first 30 odd numbers. It's going to be different. Make one of these little charts here and see if you can find a pattern. Pause it and then push play when you're ready to see the solution. So I made a little chart here. So the first odd number is 1. So the sum is 1. Second, there's 2 odd numbers. We're doing 1 plus 3. And that is 4. 3 odd numbers, 1 plus 3 plus 5. That's 4 plus 5 is 9. The fourth one is 1 plus 3 plus 5 plus 7. That's 9 plus 7. That's 16. Do you notice a pattern in these numbers? Well, to me it kind of looks like the term number squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So if that's true, then 5 squared is 25. And the first 5 odd numbers should add up to 25. So 1 plus 3 plus 5 plus 7 is 16 plus 9. 16 plus 9 is 25. So we're doing this. We're just taking the term number and squaring it. So the sum of the first 30 odd numbers would be 30 squared, and that is 900. So here we have a graph of backpack sales in 6 consecutive months. By looking at that information, what conjecture can we make about the number of backpacks the company will sell in May? So here's May. So does it make sense that this trend will continue in May? Well, they seem to kind of fit a line. And if you look at it, it looks like they're decreasing by about 500 backpacks a month. So if that trend continues, we're looking in May to be about 8,000 backpacks. So what do you think about this. Pause, and then we'll talk about it when you're ready. So, what conjecture would I make about June? Let's see, so June would be about 500 less, and I would say probably about 7,500 backpacks. Now, is it reasonable to use this graph to make a conjecture about sales in August? So that would be 2 months down the road. Is there anything that might change? Is it always going down? Is this company's backpacks just gradually going out of style? Or is this a result of kind of like a yearly fluctuation? Does something happen in August that might cause backpack sales to rise? Perhaps, since school begins in August, more backpacks would be sold. So this might not be reasonable to use this graph to project too far into the future, because there are other events that this graph doesn't take into account. If this graph went all the way back to previous years, so maybe in previous years it would be up at the beginning of the school year, down during the summer, up at the beginning of the school year, then we could follow a pattern to talk about, what sales are going to be like in August. So, in order to prove that a conjecture is true, you have to prove that it's true for all cases, for every single possibility. But to show that one is false, you only have to find one counterexample. So a counterexample is a specific case where it proves the conjecture false. So, what is a counterexample for each conjecture? If the name of a month starts with J, it is a summer month. Okay, June, July, that's cool. What about January? There's a counterexample. That means that this statement here is false because we have this counterexample. January starts with J, and it is a winter month, not a summer month. You can connect any 3 points to form a triangle. Let's see, that kind of seems to make sense. Any 3 points? Yeah, I can make a triangle out of that. Is there any case where 3 points doesn't make a triangle? What about 3 collinear points? Here's 3 collinear points that you can't make a triangle with. So that's a counterexample, which makes this statement, this conjecture, false. So how about C? When you multiply a number by 2, the product is greater than the original number. So take any number, multiply by 2, and you get something bigger than what you started with. Well, think about any positive number, and that works. If I start with 10 and I multiply by 2, I get 20, which is greater. But what if I take negative 5, and then I multiply by 2, I get negative 10, which is less than negative 5. So that's a counterexample. So just pick a negative number. Negative 4 times 2 is negative 8, and negative 8 is not greater than negative 4. Okay, pause it and see if you can find a counterexample for each one of these conjectures. Push play when you're ready to see them, or at least the ones I come up with. Alright, if a flower is red, it is a rose. How about a red carnation? There's a flower. It's red, and it's not a rose. One and only one plane exists through any 3 points. Well, not if those 3 points are collinear. Through 3 collinear points, you can have 2 planes intersecting. See if you can kind of see that. I got 2 different planes intersecting on this line, and there's 3 collinear points on that line. So there is one counterexample. Okay, so when you multiply a number by 3, the product is divisible by 6. That means 6 will go into it. So what if I do 3 times 5? That's 15. Does 6 go into 15? Evenly? No, it doesn't. That would be 2 and a half. So 6 does not go into 15. So here is my counter example. And 6 does not go into 15. Alright, that's the end of the lesson. Go ahead and start practice 2.1. Work on that until you feel comfortable with the material, and then you can start on the formal write-up. I will see you on the interweb.